Did you know that the molecular theory of matter that you started to learn about in primary school wasn't completely accepted until late into the 19th century? That is after the first Indian War of Independence. That is after the American Civil War. Well, after the French Revolution. As much as this theory feels right to us, there were prominent scientists and engineers who believed it was the wrong way to look at reality. In this session, we will see the journey of thought and experiment that has brought us to this point and laid the foundations for our understanding of matter at the most fundamental level. The oldest speculations on the nature of matter rose from Indian and Greek philosophers. Kashyapa, an Indian thinker from 6th century BC, hypothesized fundamental particles that were extremely small, indivisible and eternal, which is kind of true. He called these particles Paramanu and believed they were constituted from earth, wind, water and fire, which was clearly wrong. Greek philosophers had similar ideas. In fact, the very word atom comes from the Greek word for indivisible or uncuttable. All these ideas had bits and pieces of the truth, but they were all largely intuitively derived rather than based on a replicable observation. A better understanding of the atomic picture of matter would have to wait another 11 centuries. The first scientific theory for atoms was proposed by John Dalton. The reason he is credited with the achievement, even though similar ideas were put forward by earlier thinkers, was that he provided his postulates regarding atoms with a quantitative foundation. He was able to explain the laws of definite and multiple proportions in terms of atoms. That is, any given compound has a fixed proportion by mass of its constituents. When two elements form more than one compound for a fixed mass of one element, the masses of the other element are in ratio of small integers. More insight into interatomic behavior came from Gay-Lussac's law. Lussac stated that when gases combine to form other gases, their volumes form simple ratios with each other. Another scientist, Amedeo Avogadro, added further clarity through his discovery that under identical pressures and temperatures, same volumes of different gases carry equal numbers of molecules. So, little by little, people all over the world gradually added more pieces into this puzzle. Today, we have reached a point where we can photograph these puzzle pieces directly. For example, this is the IBM logo, created out of a collection of xenon atoms. And here we have individual gold atoms photographed by the latest investigative techniques. But remember, this is not a story that has reached its happy ending. Many of the ideas of scientists in those days have been proven wrong by later scientists. Our understanding of what atoms are and what they are not will perhaps remain open to revision and restructuring for the foreseeable future. In conclusion, I will leave you with the statement made by Richard Feynman, one of the great minds of the modern age and the father of nanotechnology. If, in cataclysm, all of the scientific knowledge were to be destroyed and only one sentence passed on to the next generation of creatures, what statement would contain the most information in the fewest words? I believe it is the atomic hypothesis that all things are made of atoms, little particles that move around in perpetual motion, attracting each other when they are a little distance apart, but repelling upon being squeezed into one another. In that one sentence, you will see there is an enormous amount of information about the world if just a little imagination and thinking are applied. Let us summarize what we have learned so far.
Manorama Horizon, learning made simple.